Okay, this is just a quick YouTube tutorial video. I'm going to record this in one go, so if I do make a few mistakes or have to correct myself, I do apologise in advance for this. If you have already attended all the research method classes, you are more than welcome to rewatch this video, but perhaps skip all the parts that you are feeling very confident with. If you have not attended all the research methods classes, you need to make sure you watch the entire video. Now, the first point I do want to make is actually not in regards to research methods, but essay writing in general. Now, the issue the majority of you do have is that you don't perhaps elaborate enough or provide enough commentary. Now, I know this is due to pressure and time constraints, so you do kind of want to pump everything out within that 30 minutes. However, if you finish your exam, you can always go back and add more things. Now, the easiest and the most clearest way to do this, which will make it a lot easier on the examiner who is also marking your work, is what I want you to do. After every paragraph, I want you to leave 3 lines. 3 lines where you can come back and write something in it. So, for example, this is our paragraph. You will leave 3 lines and then you'll start your next paragraph. When you come back to it, say you've got time and I did need to elaborate a little bit here, what I would do is I just put a number 1. So I don't want you to put a star, because stars are confusing. I want you to put a number 1 there, and then you can go and write 1 here, and da-da-da-da-da, etc, etc, etc. And so you needed to put another extra little point here. Maybe you found an actual criticism of the study you used to actually support the theory. Then, so that's an A3 point. You could just write it there as well, and it will allow you to gain more points. Okay, research methods. Now, we do know what the null hypothesis is. Basically, it's saying there is no statistical significance, so there's no difference statistically between the IB and the DV. It hasn't been found that it's actually relevant. Now, alternative hypothesis is basically the one that says that no, there is a difference. It's the one that we've set out at the start of our experiment, saying that the IB would have an impact on the DV. So there's just the one hypothesis that's saying there's no difference, and there's the other one that's saying no, there is. Type 1 and type 2 errors, we've covered this in a fair amount of detail, so I'm not going to go over it too much, but I will just let you know the easiest way to remember it if you weren't in this class. Basically, I want you to link this story to yourself, or just imagine it to yourself if you don't have any past experience. Now, focus on the thing that says type 1, true, and rejection. So the story goes, you brought your first, so that's type 1, true love home, so your first boyfriend or girlfriend or whoever was your true love, and I want you to imagine them that they were something that your parents wouldn't like. So, I don't know, insanely tattooed and pierced, or maybe far too old for you, etc, etc, or maybe they don't have a job, or whatever your parents would dislike, and therefore they rejected them. So you brought your first true love home and your parents rejected them. And that's the easiest way to remember, and you just remember that type 2 error is the opposite of that. Now, these errors happen due to interpreting incorrectly the results, or perhaps use the incorrect inferential test. Now, we're talking about significance, because significance relates to whether we think we've made an error or not. Now, significance basically links to probability. What is the chance that the effects on our DV are due to chance factors rather than, what is the probability that our effects on the DV is due to chance factors rather than our IB? Because as experimenters, we just want to have, I suppose, our IB impacting a DV. We don't want extraneous variables or anything impacting it, because then we can really and truly know that no, it's because of our IB. Now, because psychology experiments and experiments in general have so many extraneous variables and various chance factors, chance is always going to kind of affect it in some way. So we have to say, okay, how much are we going to allow the chance to actually affect our DV before we can say no, it's actually not significant, that it's not relevant, doesn't really show anything. So we set this at the start of our experiment. Usually it's been set at 0.05, sometimes at 0.01. but most of the time for psychology, just go for the straight 0.05. Now 0.05 basically means that we're allowing that up to 5% of our effects on our DV can be actually due to chance. So 95% needs to be, and as a very minimum, needs to be due to our IV for us to actually say that it is significant, that it means something. So how can we actually tell that the probability of chance on our DV is less than 5%? We need to know a few things. We need to know observed values, we need to know a critical value, and this is where inferential statistic comes in. Our inferential statistic gives us our observed value, and it also gives us our table of critical values of what we compare it to. So an example for Spearman's rho is that a correlation. A correlation is an observed value. Now, I'm just going to quickly go into Word, and I'm going to give you a little bit of a scenario, and we're going to see how this actually changes and what an observed value is. So I'm doing an experiment on my class, you guys. I'm checking the level of hyperactivity in terms of how many grams of Skittles you ate. So I'm saying the grams of Skittles, how many grams of Skittles you ate will actually impact level of hyperactivity. So level of hyperactivity is on a scale of 1 to 5. Grams of Skittles is from 10 to 50, and then I've recorded, say, after 20 minutes, what is your level of hyperactivity in relation to how many grams of Skittles you have used. That's what I'm looking at. So for 10 grams of Skittles after 20 minutes, there was no students that were hyperactive. After 20 grams of Skittles, there was only one student that was hyperactive, and they were actually at hyperactive level 2, so on and so forth. This is raw data, right? What we would do is use an inferential statistic, and a computer, it's done all by computer now. You plug all the information in, and it'll come out with just one number, right? It'll come out with one number, and that number is called the observed value, because originally we observed this value because we observe data and we record it in experiments. We generally observe this data in our experiment, thus the observed value. So we enter all this information, and out pops one value. That value can be a correlation coefficient, or it can be something else. Now, the observed value can be known as different things depending on what test you use. So it could be rho or u value, or it could be x squared for chi-squared as well. So it's basically like, you know, you've got chocolate and you've got different brands of chocolate. You've got an observed value and you've got different inferential statistics, so therefore you would have different names for the observed value. So in Spearman's rho, why I'm telling you it equals a correlation coefficient is that's because what we're going to be looking at, I'm making a link between this and the exam question that we're going to discuss. Now, to decide whether our observed value is significant, we actually compare it to a critical value. The critical value is found in the table of critical values. So we have to actually figure out which critical value are we comparing to. This will always be given in your exam. And the critical value is the number that the observed value must have reached for the null hypothesis to be rejected. So the observed value, the number that our raw data came from, and we put it in the inferential statistic, that number, we need to actually compare it to the critical value, and they must either equal each other or need to be greater or actually less than. Now, at the bottom of your table will actually tell you whether it needs to exceed for it to actually be significant, or whether it needs to be below to actually be significant. So if you can see that here. So how do we find the critical value? We need to look at a few things, because there's a whole table, as you can see, of critical values. We need to find the one which we're going to compare it to. So, degrees of freedom. Degrees of freedom is basically the number of participants. It can also be represented by N or DF. So you need to find this in your scenario. You need to read the scenario and find out how many participants you have. Then you need to also, perhaps, you need to figure out whether it's a one-tailed or is it two-tailed. One-tailed basically means that it is a directional hypothesis, that it only goes in one direction. So therefore it is one-tailed. Two-tailed is that it could be either or. It could be going into if you've got two variables, then it could be it could go in either direction as well, or cause the other could cause the other. So it's a non-directional hypothesis, and that's because there's two options. Therefore, it's two-tailed, if you want to think of it that way. Basically, one or two-tailed tells us what should our level of significance be set at. So should our level of significance be set at 0.05 or should be set at 0.01? And then you do need to know what the observed value is as well, and that will be given in the scenario. So this is actually how to answer the exam question. I've already kind of discussed this and I'm going to demonstrate this now. So first thing we need to find is the number of participants. The number of participants is 30 participants. So we can see there's 30 participants here. Remember, number of participants can be represented by n or df. In this case it's n. 30 participants, so we know that we're looking at this row. Now the question just says the result, they did a Spearman's row, they gave a correlation of negative 0.52. And we need to say, first of all, are these results significant? Now, when you are comparing the correlation coefficient, the critical value, you ignore the negative and the positive signs. They mean nothing. You only look at the number itself. So they chose a probability level of 0.05 of significance. So we look at 0.05, we know, okay, it's in this row and it's in this row. So that means it's 0.306. Now, at the bottom here it says RS, so the observed value must equal or exceed, be greater than the critical value for significance at level to be shown, at the level to be shown. So at this level, will it be significant? Now 0.52 is actually bigger than 0.306, so we know that it is greater than, and therefore we know that it is significant at probability set at 0.05. The next part is you need to explain why. Now explaining why is written in a very specific way. You need to say, first of all, that it is significant because the observed value 0.52, or you can you can start off for the number of participants. So for 30 participants, the observed value 0.52 was actually greater than the critical value 0.306. Therefore, we can reject the null hypotheses. You need to reject the null hypotheses. So either you accept it or you reject it at probability level 0.05. They're the things you need to mention. You do need to write the P and the probability level less than. Okay, so the backwards arrow with the line underneath. This is what it should look like. Okay, how to choose which test? I did discuss this, how you can remember it in class, so I'm not going to go over it. If you were not in class, you will need to come see me. There's another way you can remember it. The other way that I do mention is class is a lot easier, so please do come and see me. Right, levels of measurement. You do need to know levels of measurement in order to actually do this. So nominal data is actually categorical data, so it's actually in categories, it's not in numbers. Ordinal, the data can actually be ordered some way, so in terms of height. Interval is actually equal intervals between, so that is degrees can occur at intervals. Now, we need to come up with 2 reasons why psychologists use Spearman's row to analyse the data. So we have a quick look at this. And we want to know, why do they use Spearman's row to actually analyse this data? So you would go through that actual chart. Now, first question would be, if we quickly look at this, is it nominal data? We need to figure out if it's categorical data. The answer is no. It is not categorical data. Right? For Spearman's rho, it has to be a correlation. So they needed to use a correlation. So we can look at this and we can say there is a correlation because they use a correlation coefficient. That's our first thing. So we would say that they use Spearman's rho because the data used was in form of correlation, so it's correlational, right? So it is a correlation, it shows a relationship but no cause and effect, and that's obviously given by a correlation coefficient. That's one reason. And the second reason is, if you look at back, we can figure out that it's ordinal, and that's why they've used it, because remember, one, it can't be nominal, it has to be correlational, and then you need to figure out, okay, if it's not nominal, it has to be either, here we go, ordinal or interval, and we know it's ordinal, and therefore it is linking to Spearman's rho. And you need to be specific, you need to always refer back to the scenario. Okay. I'm just going to quickly go through just two of the past papers, not fully, just the key points. Where did it go? Right, this is slightly different. This doesn't actually give us a p-value. It just says psychologists use a non-directional hypothesis using table 1, state whether or not the correlation between intelligence and happiness at age 11 at 0.42 was significant, and explain your answer. It's worth 3 marks. So the first thing we need to do, we need to find out if it's significant. So first thing, always number of participants. So let's go up and have a look at number of participants, which is 30 children again. So we just look at the number 30. We know it's this row, but how do we know what our level of probability is? And this is where one-tailed and two-tailed tests come in. So we look at, psychologists use a non-directional. A non-directional basically means it can go either way, so therefore it means that the level of significance is actually sitting at two-tailed. But then how do we know, should we use 0.10 or should we use 0.05? We always want to use the lowest chance variable, which is significant at. And so that is 0.05, because it's much better to say that only 5% is due to chance than in comparison 10. So always go with the smallest one. So 5% is due to chance. Now, we're looking at 0.42. So we're looking at row 30. We're looking at the two-tailed, the level of significance here is 0.5. So we're looking here, just these numbers, because remember, these numbers here actually relate to the one-tailed test. So we look here, and we see 0.362, and this is 0.42, and at the bottom it says it needs to actually exceed the critical value. 0.42 does exceed this, therefore we can say it is significant, and you would then put your explanation forth. So you would mention at, you'd write it exactly the same way as we wrote it before, and you'd mention at probability level 0.05, and then you would have your 3 marks. Now, 5 years later, the same people were actually asked to complete the intelligent test for the questionnaire the second time. The correlation was negative 0.21, and it says, with reference to both correlation, outline what the findings show between the link intelligence and happiness. So we need to say, what does it show for correlation 1, what does it show for correlation 2, and what does it say overall? So we know correlation 1, at the first original one, it was shown to be significant between intelligence and happiness at age 11. 5 years later, so at the age of 16, we're looking at, 5 years later at the age of 16, we want to know what they are. So it's 0.29, remember we don't look at the negative or positive in front. This is actually not bigger than the number of participants, so therefore we know that it's not significant at the end. So you need to make some kind of comment where it was significant at the start, and therefore that however at a later age it wasn't significant 5 years later, and that's how you would get your 4 marks. Here comes the questions about peer review. You do need to know about peer reviews, etc., etc. I'm just going to go straight into a table. Right, for this, you need to identify the appropriate statistical analysis. You essentially need to draw the diagram and figure it out from the scenario. Okay? Look at the scenario and you have to figure it out. Is it ordinal data? And then is it correlational? Is it independent groups? Is it repeated measures? It is repeated measures here, but you still need to work through it. You can kind of figure it out. So you like it. There always says repeated measures, so you've got a good indication that perhaps it would be Wilcoxon. But what you need to do is make sure that you do go through the actual diagram flow chart and make sure that you are correct. It's easy to kind of pick out from little bits and pieces of information. The second one is, explain why psychologists did not make a type 1 error in relation to the difference in reaction times. So they found there was no significant difference in the hazards detected at probability as actually being more than 0.05, but there was a significant difference in reaction times at 0.01. Basically, you need to say a type 1 error is failure to reject the null hypothesis. So they're saying that why did they think they didn't fail to reject a true null hypothesis? So they're saying that basically they didn't make the error of saying there was a difference when there really wasn't, and the reason is because of the probability value. The probability value is so minimal, only 0.01% can be due to chance. What am I saying? No, 1% can only be due to chance. Sorry, I told you I'd have little brain freezes. Right. So it's only saying that 1% can be due to chance, and that's a very strict boundary. So therefore, they don't think they have made that type 1 error, because the type 1 and type 2 error can also happen because of chance factors. That say if we're allowing 10% for chance, and we're saying that there is a difference, maybe there's really not, because our range of chance is so big that we've allowed. So at 0.01 there's not really much chance factors, so they haven't made that type 1 or type 2 error. Right, for this one, you basically need to compare it. You need to start out broadly and then you need to work your way in. So they're saying that there was no significant difference between conditions 1 and 2, so just between them. So it's just saying one is not more effective than the other, but they're equally effective. So you both, just general broad terms, you need to say condition 1 is effective and so is condition 2, and then you need to talk about the standard deviation. However, condition 1 is more consistent as it doesn't actually deviate as much as the other one does, and then you need to mention that they all have a reduction. Even the waiting list has a reduction in terms of severity of symptoms. So you need to always make sure you look at the scenario. So you need to say that this is June 2014, you need to have a look at the scenario in your own time, but basically I'm saying you need to mention that they all do decrease in some way, that condition 1 and condition 2 were both found to be effective. However, this was more consistent because the standard deviation was smaller, etc., etc. Okay, so for research methods you do need to know various things: operational, non-directional. You need to know strengths and weaknesses of different forms of experimental designs. You need to know how you can test for validity and reliability. That kind of already links to depression. We did already talk about, for reliability, inter-rater reliability and test and retest. For validity, you would talk about concurrent validity, etc., etc. So you need to link back to the scenario and say, how can they test for concurrent validity? How can they test for reliability, how can they address reliability issues, etc. So you always need to link back to the question. You need to know about abstracts, how one would write up an experiment, what kind of things is needed, for you to write an experiment. So you will need to mention, your IB and DV if it's not already given, a hypotheses, how you're going to actually do it, how you're going to sample it, what is the procedure that you're going to use, how you're going to address ethics and informed consent, what are your results, how you're going to record your results. These are the kind of things that you need to mention in an experiment if they give you a scenario and you have to create an experiment. You need to know about peer review and why is it important for the scientific process. You could be asked to identify limitations of actual experiments or other studies conducted. So there's actually a lot of application of knowledge in this, and there's only very minimal definitions. Thus far there's only asked definitions about reliability, validity and content analysis, and they've also asked about the process of content analysis, which we have already discussed in class. You have to pick out extraneous variables, etc., etc. You also need to say, there's some scenarios about how would you give informed consent, or provide participants with informed consent. What would you say? Sometimes there's a few questions that link to you actually giving instructions or showing participants that have informed consent, etc., etc. Okay, this is getting way long. Okay, you need to make sure you do go over all past exam questions just to have some practice. But the thing is, not many of the past exam questions have repeated. They've only repeated the one about content analysis so far. Other than that, they really haven't. So be prepared for pretty much anything, I suppose. I'm just double checking if this one, how would you record data and explain why? So you need to say what is the most effective way of recording data. How would you analyze qualitative data? That's about content analysis. You need to explain content analysis. Alright, there was one more point that I did want to make. Just give me 2 seconds. Right, and you might be asked to whether you're going to use self-report measures, and are you going to use questionnaire, you're going to use an unstructured interview, you're going to use a structured interview. So you need to know what the benefits and the limitations are for each of those four. Questionnaire, self-report, they're perhaps more willing to give information because it's anonymous, whereas if you were in a structured interview, there wasn't that level of anonymity between the researcher and the participant, but you've got good controls. But in an unstructured, you can actually come across different information than you would in a structured. So you need to kind of mention that if they're asking what is better or what is the best thing for you to use in terms of the scenario that is being given. Okay, I think that's enough rambling for now. Hopefully I haven't gone too long. If you've got any questions, please email me. Okay.